3 lessons. Like I called it lesson 0, and then lesson 1, lesson 2, lesson 3. Okay. All right. So a 3 lesson. However, I'm going to say that this lesson could be 2, right? And lesson 3, I do break up into 2. So there's a lot. So that's why it's a test and not a quest. All right. Let's look at the learning goals of today. There are some big ones. So the first thing is we're going to determine the values of any primary trig ratios for angles in standard position. What is the new term there? Standard position, right? What is standard position? So let's make sure today that by the end of the lesson, you sort of have a good understanding of what standard position is. Next, predict the sign, positive or negative, of the primary trig ratios for any angle in standard position. So the second learning goal is all about predicting if the ratio, sine, cosine, tangent, if it's going to be positive or negative. Not the angle, but the ratio. Then we're going to use special triangles. What? Yes, special triangles to determine exact values for primary trig ratios. So 3 big pieces. Understanding how does an angle look that is in standard position? Secondly, understanding if the ratio is positive or negative. And thirdly, we're going to look at some special triangles, okay, as a way to do trig without a calculator. So first of all, let's look at standard position. So I highlighted that pink. Okay, so this diagram here shows us an angle in standard position. I want to show you the difference between last unit and this unit. So last unit, we did see some rotational trig. And that was when we looked. So folks, look at the screen here because I'm showing a demonstration. So in unit 6, we were looking at using the bearing on a compass. And when you're reading a compass, 0 degrees is north. And if you're given an angle, you're moving clockwise to find that bearing, right? That is different in this unit. We're not using a compass. We are now using a Cartesian plane. And 0 starts at the positive x-axis. And so if I give you an angle, you start from the positive x-axis and you open up until you hit that angle. And this line here, the red line here, is called the terminal arm. Terminal means final. So the angle starts at the positive x-axis and it ends at the terminal arm. Notice that when we draw an angle in standard position, we use a directional arrow, right? We're showing that the angle is opening counterclockwise. That tells us it is a positive angle. What would happen if my angle was opening clockwise? It would be negative, okay? Now, I want to show you an angle that is not in standard position so that you can kind of understand a little better what is standard position. So if I were, in our word problems on the test, we had Susanna running, someone else, whatever, right? And there's an angle between these two lines. This is not in standard position. Why isn't it in standard position? Yeah, Alex.
Is this like on a compass?
Sure, but why is this not in standard position based on the definition that I just started describing? Yeah.
It's going from, based on north is 0.
Yes. Okay, the compass stuff. Where is it not starting? Where is it not starting, folks?
Positive.
positive x-axis. If I wanted to take this angle and draw it in standard position, don't draw this purple stuff. I would have to start here and open it up as far as it goes. It would have to start at the positive x-axis. Do you see that? So the purple one is not in standard position because it doesn't start on the positive x-axis. Okay, so I'm going to highlight the positive x-axis and show that an angle in standard position is the measure from the positive x-axis to the terminal arm. Right, so I'm kind of color coding it here. So you can take any angle and redraw it in standard position as long as you're starting at the positive x-axis. And since, so the positive x-axis is 0 degrees, since we're moving counterclockwise, what is the angle at the positive y-axis? 90. What is the angle at the negative x-axis? Okay, 270. And then when I go back, it's 360. So do you see how this is rotational trigonometry? The terminal arm starts here and it rotates until it hits that angle. But that angle could keep rotating and keep rotating and rotating and rotating, right? What if I do one full rotation, how many degrees is that? What if I do 2 full rotations? What if I do 3 full rotations? 1080, right? What if I do 1 backward rotation? Negative 360. Okay, that's what I mean with rotational trig. We're rotating around the Cartesian plane, the x and y axis. Okay, now this big angle and this little angle are related. What do we call 2 angles that together make 180 degrees? It's not complementary. Complementary makes 90. These 2 are supplementary angles. Okay? Now, I give this little acute angle a special name. I call it the RAA, and that stands for the related acute angle. The related acute angle.
What angle are you talking about?
Yeah. This angle here. Does that help, Lauren?
Yeah.
Thank you. So when I have this big obtuse angle, I know that if I punch it into my calculator, I won't get the right, if I put a ratio into the calculator, I won't get this big obtuse angle. Remember how it was with the ambiguous case? When you did the ambiguous case, you always got the smaller, the acute angle, and then you had to do your own calculation. Well, that remains true here. And so that's why we find the supplementary angle. And we're like, okay, the supplementary angle and the acute angle and the obtuse angle, because they're supplementary, they're actually going to have similar ratios for cosine, sine, and tangent. Okay? So this related acute angle is going to be helpful for us. Okay? All right. Now, once we have a terminal arm, we can take any point on that arm. Okay, let's say we've taken a random point here, and that point has an x and y coordinate. Well, that x is really, if you drop that x, that is how far along the x-axis this point has gone, and the y is how far up that point is. Do you see? So this point here actually gives you the length of the sides of a right angle that is formed in that related acute angle. you want me to say that again? No, yes?
Yes.
Okay. Okay. So what I'm doing is I'm trying to figure out the ratios of this big angle. But I know I can't just work in that big angle. I have to find the related acute angle. And so I have this related acute angle. And so what I can do is I can take any point along the terminal arm, find the x and y coordinate, and the x will give me this length, the length of the horizontal, and the y will give me the length of the vertical line in this right angle triangle. Okay? This is going to be helpful because I can find opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, going back to the primary trig ratios. Now, the r value I can't find from the point. If I'm given a point, I have the x and y. How do I find the r? Well, the r is the hypotenuse. And that takes us to the right angle theorem, or the formerly known as the Pythagorean theorem, where r squared is y squared plus x squared. And so to find r, to find the hypotenuse of this triangle, I can use the right angle theorem. Yes?
Are you trying to find like the size of the triangle, or are you trying to find the angle?
What I'm trying to do, what we will be trying to do, is finding a ratio. So I'm not looking to find the angle, okay? I'm trying to find a ratio, okay? What is the ratio? The ratio is the comparison of the two sides, okay? When we have a small angle, we're going to have one type of ratio. As the angle gets bigger, that ratio is going to change, okay? One ratio that has been really helpful. What is the ratio for sine 30? Do it on your calculator. I wonder if anyone's recognized that I kept doing it on the test. 0.5. That's a really helpful ratio. So what I'm saying is opposite over hypotenuse, the hypotenuse is twice as long as the opposite, right? Because it's 1 over 2. So this ratio tells us how long one side is compared to the other side. It's an actual helpful number. So we're going to be working with ratios. Now, in order to do that, notice we are now outside of quadrant 1, right? This is quadrant 2. This is quadrant 3. This is quadrant 4. So in rotational trig, your angle will be in any of these 4 quadrants. So we need to understand how the quadrants affect sine, cosine, tangent. Okay, now folks, I just want to say, bear with me. I know this is a lot. Okay, we'll do some examples to bring it together. All right, so let's look at our quadrants. We've got quadrant 1 here. If my terminal arm is in the first quadrant, I take any point, I draw the x and y, and all I care about, I don't care about numbers right now, I care about positive or negative. So if the x dot is right, if the point is here, is the x value of that point going to be positive or negative? It's going to be positive, right? Like what I mean is this dot could be 1, 5, right? And the x and the y are positive. So the y is also going to be positive. Versus, look in the second quadrant. If my terminal arm is here and I take a point, what is the x value here? Like if this is a graph, what is the x value here? Is it positive or negative? That's the difference. How about the y? If I'm going up, is it positive or negative? Okay, so in the first quadrant, we've got positive and positive. In the second quadrant, it starts to change. The x will be negative. The y will be positive. Now, let's look at the r. To find the r, I have to square both terms and find the square root. So let's just take an example. If, let's say, both of my x and y's were negative, if I had -3 squared plus -7 squared, what will my r value be? Yeah.
Root 58.
Well, sure. Is it yes, sorry. What I mean is, will it be positive or negative? Positive. Is it possible with this formula to get a negative r value? No. I'm not using complex numbers. So no. So what that tells us is that in every single case, r is always positive. So the r value in these graphs is always positive. So going back to quadrant 1, I'm using green for positive, red for negative, just so you understand my. So what I've got here is that x, y, and r are all positive. Okay. Now, if this is my angle, the opposite is y. Let me zoom in on quadrant 1. The opposite of this angle is y, the adjacent is x, and the hypotenuse is r. So we came up with these formulas based on that. So for theta, opposite over hypotenuse is the y value over the r value. Cos is adjacent versus over hypotenuse. So that's why it's x over r. That's how we came up with these formulas. Now I don't want to put any numbers in. I just want to put positives and negatives. So for sine theta in the first quadrant, y is going to be positive, r is going to be positive. So if I'm dividing two positive numbers, what does that give me? Positive. Now, do you think any of these are going to be negative in the first quadrant? No, because there's no negative, right? It's always going to be positive divided by positive. Positive divided by positive. So what I'm finding is in the first quadrant, sine, cosine, and tangent, the ratio, not the angle, the ratio is always positive. Sometimes you've punched in angles into your calculator and you get a negative ratio and you're like, oh my God, it's a mistake. And it's not. It's just that you're outside the first quadrant. So our conclusion for quadrant 1, I'm going to use a big letter, is to say that all ratios are positive. All ratios are positive in quadrant 1. So it's alluding to the fact that this won't be true in the other 3 quadrants. So let's figure this out. Okay, migrating to quadrant 2. So I'm going to use my highlighter to show which values are positive and negative. Which one is always positive? R is always positive. Okay. Now in quadrant 2, is y positive or negative? Y is always going to be positive in this quadrant because this is always above the x-axis. So all the y values are going to be positive. How about the x values? They're always going to be negative. Okay, so I'm going to use red for that. Got that? And so all I want to figure out is which ones are going to be positive, which ones are going to be negative. So for sine, it's y over r. Y is positive, r is positive. So in quadrant 2, the sine ratio will be positive. How about cosine?
It will be negative.
So x, yeah.
And front one will be also negative.
Beautiful. Yeah, so Andre's saying, hey, if x is negative, you have negative over positive. And tan is y over x, so that's positive over negative. Well, that's still negative. So in this case, in quadrant 2, there's only one ratio that is positive, and that is sine. And so that's our conclusion. We will say that sine is positive in quadrant 2. So I will write these capitalized letters right at the origin, because what we're doing is we're deriving a rule. We're using some information, some formulas that we know, and we're deriving a rule. So let's move on to the third quadrant. Okay, first things first. Is x positive or negative? Is y positive or negative? And r positive. Good. As such, sine is y over r. Negative over positive. Cos is x over r. Negative over positive. And tan is negative over negative. Good. So the tangent, if your angle ends up in quadrant 3, tan of that angle will be positive. So what is our conclusion? Tan is positive, right? So we draw a big T. Tangent is positive in quadrant 3. And in this on the origin, I will draw a purple T for myself. So far I've got AST. Any guess, any prediction, what will we get in the fourth quadrant? Okay, let's see. Okay, so I'm going to highlight what is going to be positive. So the x is going to be positive, the r is positive, but the y is going to be negative because it's under the x-axis. Okay. So y over r is negative over positive. X over r is positive over positive. And tangent is going to be negative over positive. As such, our conclusion is that cosine is positive in quadrant 4. And so I draw a C at the origin, and I introduce to you what is the name of that rule. Is it Saktka? Is it Astka? What is an easier one to say? Cast. This is called the cast rule. Okay, just because it's easier to say. Okay, we will use the cast rule. Okay, so let me introduce on the next page, we have a summary of the cast rule. If you're still a bit rusty with which quadrant is which quadrant, then you just keep writing it over and over again. And what the cast rule tells us is it tells us which ratios are positive. So let's skip this next part. We're going to come back to the special triangle, but I want to do an example using what we just did. So we're going to look at example 1. We are given that a point P has its coordinates, and that point P lies on a terminal arm in standard position. Determine the exact values of sine, cos, and tan. All right, let's draw that terminal arm. So if that terminal arm is at -3, -6, which quadrant is that terminal arm in? It's in quadrant 3, right? So here's my point. It's -3, -6. And the terminal arm goes from the origin through that point. And in order to draw it completely in standard position, I have to show the rotation, right? So I start on the positive x-axis and I rotate around to the terminal arm, and I must draw the arrow and a theta to show, hey, this is the angle we're working with. Okay, now what information are we given? Well, we're given the x. The x is -3. We're given the y. That is -6. What do we need to find? We have to find r. Can we do it? Yes. Because r is the square root of x squared plus y squared. We're going to do this in our head as best as we can. We are using exact values, right? Because we were told to find exact values. So exact to me tells me no calculator. No calculator. So I have 9 plus 36. That's root 45. And how many people simplified that radical? Okay, going back to unit 2. Remember, if you can, you must simplify the radical. So what is a multiple of 45 that's also a perfect square? Say it out loud. Beautiful. 9 times 5. The square root of 9 is 3. So r equals to 3 root 3. Now, if you are... No, it's not 3. Thank you. Oh my gosh, you were so good. Thank you. Jury's still nice. She's like, really? I don't think so. Where Kivrin's like, no, you got it wrong. I did. So ideally, you're communicating this way. You're reducing, you're simplifying radicals. You are rationalizing denominators all the time. Okay? However, I won't take serious marks off on the test, but I will count it against your communication mark. All right. So we are asked to find sine, cos, and tangent. Okay. Sine of that angle is going to be y over r. What is y? Y is -6. What is r? 3 root 5. There are 2 things I can do here to simplify. See if you can remember. So first one, I'm going to divide 6 and 3 by 3. So I get 2 and 1. And why is Miss Sly feeling icky? The radical's in the denominator. So what is the process of getting the radical out of the denominator? What is the name? What's the name? 5 points. 5 points. Yes. Rationalize the denominator. So how do I get rid of this radical in the denominator? I multiply the numerator and denominator by root 5. And so what happens is essentially the root 5 moves up and the denominator becomes the radicand, right? It's a bit of a pattern. Okay, let's find cos of theta. So cos is going to be x over r. So my x is -3. Once again, I must rationalize the denominator. Now the 3's cancel out. So I have -1 over root 5. You don't have to show the rationalizing. Like you don't have to show root 5 over root 5. At this point, rationalizing the denominator is like reducing fractions. It's sort of second nature. It's something that it would be great for you to be able to do it in your head. The last ratio we need to find is tan of theta. And tan of theta is y over x. So we have -6 over -3, which simplifies to +2. Now, I want you folks to think, does that make sense? Okay. Does it? Thumbs up if it makes sense. Why does it make sense? Talk to the person next to you. All right. Yes. Yes. All right. So it makes sense because tan is positive, sine is negative, cos is negative. And we are in, if we draw the cast rule, in the third quadrant, tan is supposed to be positive, and it is. All right. Let's look at an opposite example. Let's look at example 3. Okay, we're skipping example 2 for now before I do the special triangles. All right. Read the question. Okay, for theta in standard position and determine cos tan given sign. All right, folks, back here. All right, we are told this. This is a restriction. It's telling us that the angle has only done can only do a maximum of one full rotation, right? Because what is 2 pi in degrees? 360, right? So what we're saying is that theta is between 0 degrees and 360 degrees. If I said it's between 0 and 720, what I'd be saying is, hey, we've rotated 2 times. So you might have multiple, like 4 angles. Okay. So when theta is in standard position and it has only rotated a maximum of 1 time, we are given that sine is -3 over 7. So we don't know the angle, and guess what, folks? I'm not being asked to find the angle. What I'm asked to find is what is tan of theta and what is cos of theta. So I'm asked to find the other 2 ratios. So let's problem solve. Let's figure out what we know thus far. From sine -3 over 7, there's quite a lot of information that we have. What is one thing that we can get from that? Yeah. What is the y value? Okay. And are you sure that the 3 is negative as opposed to the 7? Because you could have just dropped the negative to the 7. Why is it that 100% it's the y value, it's negative, and not the r value.
Because R is always positive.
You got it. R is always positive, remember? Because of the right angle theorem. So in that case, we can say, okay, R is 7. From here, what can we find? We can find the x value. Okay, I might need to rearrange the equation, okay, because I know that x squared plus y squared equals r squared. So x squared is going to equal r squared minus y squared. And so to find x, I will take the square root of 7 squared and subtract negative 3 squared. 49 minus 9 is 40. Can I simplify that radical? Absolutely, Miss Sly. What's the greatest perfect square factor of the radicand? Oh, that's really funny. 4 times 10. All right, and so it simplifies to 2 root 10. Now, in theory, you're like, okay, we've got everything we need. We're just going to plug it in. But we're not actually done, because now we have to consider which quadrant does theta end up in. So what information from this given statement will tell us which quadrant we're in? The negative or positive. So because sine is negative, I want you to talk with your elbow partner. In which quadrant might you find the angle? How many quadrants, folks? Is it 1 quadrant or 2 quadrants or 3 quadrants or 4? Good. Folks, will the angle be in quadrant 1? No. Because, oh, I wrote cast wrong. Wow. C, A, S, T. In the first quadrant, everything is positive. Will the angle be in the second quadrant? No, because sine is positive. Can the angle be in the third quadrant? Yes. And can it be in the fourth quadrant? Yes. So what that means is we need to create 2 sets of ratios. So we'll start off by giving the ratios in quadrant 3. Yes.
Wouldn't it not be in T because X is positive?
In which? 3?
Yeah.
But so is y. Sorry, in 4.
I mean, we found that. So, and so,
No, but if we're in this quadrant, then x becomes negative, right?
oh, right, because it's yeah.
Yeah. So that's a good point. So Kieran's suggesting, okay, but x is positive, 2 root 10. So doesn't that mean it can't be here? No, it still can be. It's just we would write 2 root 10 as a negative. These are just the values, but we can add a positive or negative. So in quadrant 3, cos is x over r, right? So what is my x? My x is 2 root 10. My r is 7. So I've got the numbers. Now I have to think, is it positive or negative? Okay, so in quadrant 3, is cosine positive or negative? Okay, I just lost you guys. Take a second, copy it down. That's okay. Okay, I'm in quadrant 3. Watch here. In this quadrant, will cosine be positive or negative? Negative, because only tangent is positive. And so all I have to do is add a negative sign. Right? I don't have to say which one is negative. I mean, it's obvious the x's because r will never be positive. Will never be negative. But I don't have to show that. I'm just like, I know it's negative. Okay, how about tangent in quadrant 3? Is it positive or negative? It's positive, right? Tan is positive in quadrant 3. So tan is y over x. What's my y? My y is, I'm just going to write 3. All right, sure. I'll write negative 3. What's my x? My x is negative 2 root 10. And they cancel out. Yes. Yeah. The x in quadrant 3, the x goes this way. So the value is 2 root 10, but because it goes backwards in the negative x-axis, it is negative. So all I did here is find the value. I need to assign a sign to it. So I've got 3. See if you can rationalize this denominator. I'm going to do you guys a great favor. And I'm going to teach special triangles tomorrow. Yeah, because I feel like period 1, their brains were totally fried. Okay. So we can have this angle can either be in quadrant 3, but it can also be in quadrant 4. In quadrant 4, the x's, y's, and r's are the same. The only thing that changes is tell me about cosine in quadrant 4. Oh, now it's positive. So I take 2 root 10 over 7, and I just make it positive. And for tangent, in quadrant 3, it was positive, and now it is what? Negative. Yes.
For tangent theta, quadrant 3, isn't it over, isn't 40 the denominator, not 1?
Isn't 40 the denominator? No, because I multiplied everything just by root 10. So did you multiply everything by 2 root 10?
Yeah.
Yep. But that would also mean that your numerator would be 6 root 10. And then you would reduce the 6 and the 40 to 3 and the 20. Okay. So what we mean is what we've seen is when your sine ratio is negative, it means you can either have an angle in quadrant 3 or you can have an angle in quadrant 4. There's 2 possible angles that satisfy this ratio. Yes?
Oh, I was gonna ask why you keep before you just said cos and tan. Is that just the signs already given?
That's correct, because we're being asked, it says determine cos and tan given the sign. Yes. So folks, I have left out the special triangles. I love them. I'm sorry. I know you're going to have to wait one more day. I'll look at them tomorrow just because I think we've already done a lot. So I just want to look at the homework to see if special triangles come up, and I'll tell you which ones not to do. Okay, so let's look at the homework. You can do 1. You can do 2. Okay, don't do 3. So for Wednesday. But maybe it's better to say for Wednesday, right? Wait, let me stop recording.